Okay, so this is Kubernetes Identity Working Group for November 2017. We've got two things on the agenda today. We've got Mike and CJ presenting on kubernetes-sig-auth OIDC provider, and we've got someone from Yahoo presenting. Is the Yahoo person here?
Yes, I'm here. Hi.
Great. Hey, I'll try and keep time and split this at 30 minutes if that works. So I'll hand it over to Mike and CJ to get started.
Hi guys, how's it going? So we kind of wanted to go through some of the stuff that we were planning on prototyping. We had a few design questions that we want to get feedback on. CJ, do you want to present? Can't hear you. Uh-oh.
You're muted, CJ.
Oh, there. How's that?
Yep.
I'm talking and now I'm trying to also present. Can you see my screen?
Yep.
Okay. So I think we talked a little bit about the baseline thoughts around this before. This is a little more detail of what would happen if Kubernetes became if an individual Kubernetes cluster became an OIDC provider. When you set up your cluster, you would need to do some pre-work to get the discovery doc that your cluster was serving and push it to a publicly accessible, probably with publicly trustable certs. Although I think that was a requirement of OIDC. Mike, you can correct me if.
Yeah, so this is actually if your master is not hosted on the public internet and that OIDC configuration, OpenID configuration doc is not actually publicly accessible. There's some process that you need to take to publish it. The example here just publishes it to storage.google APIs. And I think you are correct in saying that as part of the spec, the certificates hosting the HTTPS server that is serving the OpenID configuration need to be publicly trusted. So that's the step 3. Do you want to continue?
Sure. And then the thing that you're trying to get to trust your Kubernetes cluster, you need to point it at that location. And there's probably some API that says, hey, trust my Kubernetes cluster. Its configuration is here. And so we were thinking, just taking the Google example, you might have a few steps to create a pod with a external identity where you first create that external identity and then you somehow bind the Kubernetes identity to be allowed to act as the external identity. And from there, you somehow get to magically use that identity inside a pod. So one of the things that we were looking at is what is the best way to define where in the API should we define an external identity? Should we hang it off of the existing Kubernetes service account? Or would it make more sense to users to hang it off the pod, even if the mechanism for getting that identity ends up indirecting through the Kubernetes service account?
And in the case of an AWS account, this would probably act as a role. So
I'm sorry, you guys are moving pretty fast here. Can you move back a couple of slides? All right, so what you're the IAM one. Okay, so essentially what you're saying is that you have OIDC, you configure some external thing to trust your OIDC, and here you're doing it based on service account, right?
Yeah, so this is pretty Google specific. We're like trying to go through what it would look like with our existing objects in Google land, and we have a service account object, and there's a role called service account actor that you can grant.
All right, no, but I'm looking at the -- member is essentially a reference to the service account as identified through OIDC.
Yeah,
Yep.
the Kubernetes service account.
So that doesn't exist today, but we're thinking,
Yeah, that's a sketch of what that might look like, right?
Kind of somewhat similar mechanism exists like on AWS, where you can create federated user pools.
Yeah.
Oh, cool.
Okay.
And
So here you're essentially saying that I'm going to let my Kubernetes service account act as the GCP service account, and the way you're identifying the Kubernetes service account is through OIDC. Okay.
Right.
I just want to wrap my head around that. Sorry.
Yeah, sorry, I cruised right through that.
And then the next slide, and then the question is that what is the thing that you're actually saying, hey, I want to be able to act, well, why does GCP need to actually, why does Kubernetes have to play here at all?
So if we do this exchange model,
Yeah.
then somebody has to know what it's exchanging for.
Okay, but just to be clear, so like one option would be that you write code in the GCP API library that knows how to actually do the OIDC dance to actually verify and essentially hoist your Kubernetes service account into a GCP service account, right?
Right.
And in that case, you don't need to annotate anything.
No, actually, I think I think there's a misunderstanding. So you have to know what role you want to assume. Just like on AWS, a client library comes up, even if it does the dance, the simple token service, it needs to know who to ask to become.
Right. So the workload needs to know which identities does it want to actually act as, and then somebody has to do the dance to actually turn the Kubernetes identity into the GCP identity. Right?
Yeah, that's part one of why Kubernetes might want to know. Part two of why Kubernetes might want to know is we might want to lock down a namespace in a way that beyond the checks that we do in RBAC, we might also want to check that a user acting in that namespace is allowed to impersonate a service account or act as a service account. Because essentially, when you allow a user access to a namespace, you are also allowing the user access to external service accounts that that namespace is allowed to act as.
Right, and so you could do that with another authorizer with deny, right?
Yeah, admission controller or something, yeah.
You can make a subject access review of, can Joe impersonate or act as, maybe we don't want to overuse impersonate, can Joe act as the service account, GCS at my project, whatever. And it just calls out to the authorizers you have configured.
Or I would...
That seems a little bit like, okay, yeah. That seems a little bit tightly coupled.
So I would actually do this with an admission controller, an extensible admission controller, probably, where if I wanted to have a strong enforcement of my external identities, and I don't think that trust or the act as permission is transitive through Kubernetes service accounts. And what I mean by that is, if user A can act as a Kubernetes service account and that Kubernetes service account can act as a Google service account, I want to check that user A can also act as the Google service account. I don't want to trust the transitivity of that link before I allow user to act as the original service account. I think that's some enforcement that certain external identity providers want. And I think that the best way for that to be enforced is for that external identity provider to deploy a admission controller dynamic webhook. The dynamic webhook admission controllers that enforce that.
Go ahead, Moore. Sorry.
So if I could rephrase, make sure I understand. So basically the problem here is in the third-party system, in the Google system, you've given a particular service account name special privileges. So along with those special privileges might come extra authorization checks that need to happen sort of with all the object creation that involves that service account name. And so that's where you might need like a special admission controller now to like prevent a user from creating a service account with that name or running a pod as that service account. because those actions imply that you're accessing that third-party system now because of the linkage.
But it seems like this is going the other way around.
Yeah, I'm not sure I understood the whole transitive thing. Like,
So let me try to rephrase it. User A can act as a Kubernetes service account A. Kubernetes service account A can act as the G service account A. I set up permissions such that user A can do stuff in namespace where service account A lives. So that user can create pods, therefore they can create pods with service account A. Then they can exec into those pods and they can take credentials, assuming I don't do any checks, they can take credentials, they can take the ID token and exchange that with Google to get an access token for Google service account A.
So what you're saying is that you wanted a mission controller that says anytime a user tries to act in this namespace, I want to look at all the service accounts in this namespace, look to see if they're mapped into GCP service accounts, and then deny if that user doesn't have access to those GCP service accounts so that they're not expanding, right?
I want to have a external identity provider integration have the ability to implement that.
Yeah, okay. So I don't see why that needs an annotation on any GCP things, because like this is the stuff that user is setting here for these annotations on the service accounts. Like that can get disconnected from the information that's actually stored in GCP. The GCP is the thing of record to actually figure out who can actually, represent whom.
Right, unless we create a stronger link between them.
Yeah.
I get you.
I'm also a little bit worried about, the way that you're identifying these things with the OIDC discovery document or discovery, thing. Like what happens if that changes over time, right? Is that an exploit, right? So if you had something like some sort of signature of that thing that actually was invariant. So it's like where to find it is one thing, and then some sort of unique cryptographic identity around that OIDC provider. Because if somebody brings down a thing and then brings it back up, are you going to have stale credentials and who's caching what, when, and where? So I would, that's something that I would think about there also.
Yeah.
Part of the idea with OIDC discovery is that you are letting it change over time. Which actually, I think that's kind of a related problem here is if you're talking about installing a cluster and then doing a one-time copy of the OIDC discovery into like GCP storage, that precludes you being able to rotate the key without doing that copy.
Right.
Rotate it.
The discovery document just points to the key. It doesn't actually hold the keys.
Oh, it doesn't hold the key.
It just points to another URL where you get the keys, and that has semantics around rotation that are defined in the spec.
Yeah,
I thought you said that. Okay, I'm okay. That's interesting.
It makes sense.
We would need some process to synchronize keys, definitely. The cryptographic identity is the HTTPS serving certificate of the server.
That's serving the document.
Yeah, certain providers allow thumbprinting of those server certificates, so you can actually pin a integration to a specific hash of the server certificate.
Okay,
so in a lot of cases too, you just do this discovery instead of publishing it. You just do it out of band, right? You just upload I think that's how AWS handles it. I don't think they actually do discovery by URL.
I think they do discovery by URL.
Okay.
All right, so backing up a little bit, the goals here look to be like implement OIDC so that you can assert Kubernetes service account identity and actually use that in a federated way, right? There's annotations that you're going to put on something so that the workload gets a hint in terms of which identities it should try and use, right? There's no guarantee that annotation lines up with what GCP actually is knowing. Right. So you could actually try and do that and it could fail, but things are out of sync, that stuff happens. So this is really more of a hint to the workload in terms of which things it should try and actually translate, right?
Right.
And then there's the question of, is there a component like a flex volume or something like that does that automatically for you so that you don't have to so that you don't have to actually have a lot of client code to do the OIDC dance, right?
Yeah, and we actually have some slides on that too.
Sorry, I'm jumping ahead then.
No, thank you. It's the right train of thought.
And then
yeah, I would be a little bit clear about the different goals and the different sort of like which parts of this proposal actually hits each of those different goals and scenarios. And I think like, and there's user stories, like the user wants to be able to actually act as a GCP service account. And so we do this through X, Y, and Z. Okay, the administrator wants to make sure that users don't use that to escalate privileges. So we're going to do that through mechanisms A, B, and C, right? I think for me, that would make this a little bit clearer.
Okay. Anything else, or should I move on?
Sorry.
Yeah, let's move on.
Okay. Yeah, so the question here was kind of where logically does it make sense for users to be thinking about these hints if we do have these hints? And if we do want to support attaching external identities as part of the API instead of something that applications have to reason about completely on their own. Let's see. So yeah, Mike, you can talk through this. This is kind of what in our heads we think happens from the time that you submit a pod spec that includes this hint or a service account spec.
An admission controller would add that Kubernetes or some flex volume to the pod, and potentially an environment variable to hint to the client libraries, which service account to act as in the access token exchange. And then kubelet would start up, build a pod, build a flex volume for that pod with Unix domain socket or some credentials stored on disk, or a metadata server, however we choose to expose that, however we choose to expose the workload agent, and the pod would start up. Client libraries would talk to that workload agent.
I think, Mike, you should show the slide with the picture. It's much to absorb. Yeah.
Okay, so this is our model one, where we have really thick client libraries and a very generic node agent. The node agent can be exposed over to the client libraries in numerous ways that we've discussed to death. The client library asks the node agent to get an ID token. The node agent is responsible for grabbing it from the Kubernetes API and returning it to the client library. That ID token identifies the pod as the Kubernetes service account, and the client library exchanges that with Google to get an access token. So this is model one, where we have thick client libraries and very generic node agent.
So quick question on that, like, Mike, I mean, do you even need a node agent there? Because we have the existing JOT-based service account mechanism that you could use to essentially prove your identity to start.
We're kind of circularly arguing, though. We're trying to tear that out, possibly.
Okay, so yeah, I think is this a mechanism to actually tear that out and make service accounts be more generic, or is this a mechanism to actually bridge to GCP? Is it both?
Both.
Okay.
The other difference
I think should be pulled out here in terms of a goal for this.
The difference, I assume, is when you're making this call to get an ID token, you're specifying an audience. That's not the Kubernetes API server, which is impossible.
So the JOTs that we have today are very unusable for this purpose.
Totally agree. Yes. So you don't want to take a dependency on the old JOTs because we want to be able to deprecate and actually make those be more specific. Is that the case?
Yes, we definitely don't want to take a dependency on those old JOTs because we want to turn them off.
Because I mean, what you could do is if the OIDC provider is part of the Kubernetes control plane, you could use our existing JOT as a way to represent identity to that, so that you could actually get a more specific JOT for actually doing the OIDC.
Right. But I think we just want to remove those old JOTs. So
okay. Sounds good.
And I think part of this is we want to be able to push towards, we want to have the option to not have to make availability security trade-offs, and maybe have the node agent do some sort of pre-work, some of the stuff that we talked about before with like proof of possession of keys, and we went down the talking about.
But I mean, getting to the point where you don't have to talk to some sort of SPOF here is great. So
yeah.
That was going to be my question too. Is the node agent here doing the kind of two-level JOT thing that Mike's proposed, or is this Just
Not
calling
in
back to
this
central issue.
example. This is just kind of the simple version with just getting a jot and sending it off. But then, yeah, you kind of get at the point that we want to be able to have the node agent hold something that it doesn't need to synchronously go off to the API server for.
At some point, you need some sort of signing certish chain, right?
I think that it's really nice to have that property, and I think it's important for this use case. It's also going to not be compatible with most OIDC relying parties.
Yeah, I'm hoping that token binding will change that, and it's the RFC draft is fairly far along. I think that'll be the standard that most people adopt.
Wait, is token binding the similar to what we were discussing in the trustworthy JOTs, or is it a completely different thing?
Yeah, it uses that CNF claim
for like proof of possession of a private key.
Yes.
Okay.
All right. So
and then I think if we could jump to Model 2 really quick and show the alternative. So the alternative is to have thin client libraries and Google plugins, or potentially like a Google node agent. So we run a node agent per provider, and we offload the exchange for access tokens or access keys and secrets to the node agent. And the client library requests a external identity specific credential from the node agent. So these are the two models that we wanted to get feedback on, the pros and cons of each. Maybe we can go to the pros of one. We think one is nice because node agent is general, no prior knowledge of external systems. So developers can add an integration with an external system without root permission, but you have more complex client code. And client 2 is the modifications to client libraries are small, and maybe we have to run smaller sidecars. But adding and maintaining identity provider plugins or identity provider node agent has cost on the operation of the cluster. So this is another design decision that maybe we wanted to get some feedback from you guys if you had opinions on it.
So is one of these like really a sidecar approach? Because you could, in classic stance, you could do like a number 1, but instead of having it be a client library, you could have it be a sidecar coordinating through a volume.
Yeah, I think there's lots of stuff you could do there. Like we could even spoof the metadata server type thing in a sidecar.
Yeah, the thing that I like about number 1, which I think is a big thing, is that as like right now you're thinking about, well, the administrator wants to set up an equivalency between this and sort of GCP, right? But as you start thinking about like how are there going to be other systems that are maybe not GCP, and maybe those things are going to come and go, and maybe those things are going to be application specific. So can I now use this service account identity to authenticate with something that maybe my administrator doesn't even know about, right? I guess it's not precluded with number 2 because you still have access to the JOT and you could use that. So it's not necessarily an either or thing, maybe. I don't know.
So I would consider a sidecar, a smart sidecar. I would consider that falls in option 1, because that runs in user-defined code. Whereas option 2, the integration and the stuff that does exchanges, runs in the administrator's realm.
But I think Joe's right. It's not either or. Right.
Yes.
Well, for the Google thing,
integration, I guess. Like, would you do either? Would you do both for GCP?
No, not for a particular provider. But
Right.
like, if we built option 2 for some, widely used IDPs that doesn't sort of stop, like one of the cons was, you need the cluster administrator, which is sort of true if you want it to work this way, where you just ask for the identity directly from the node agent. But for some rando identity provider that some application person wants to like authenticate with, they can just do it in client libraries and exchange their Kubernetes jet, like
I think that's fair. But
version
then
one.
it's a question of like, do you support these two tiers, first class integrations and second class integrations, and is that worth it? But
I don't know. I mean, it also makes the API more complicated,
Yeah.
right? Like this node API needs to understand that you're not just asking for your own identity. You have to be able to like select what other identities you want to get access to. I mean, I guess you sort of do have to do that in the other one, where you have to ask for the audience for your job proof. But
I'm a big fan of having a sort of a generic like jot minting endpoint. That's sort of the interface. And then if you want to trade that in for a GCP token, a GCP identity or AWS identity or something, doing that in a sidecar or a smart library, it makes the most sense to me, rather than dragging that into the node agent. And not just into the node agent, but into the interface that's there.
Yeah, so I guess the point made by Joe is we can deploy both of these on the same cluster. What do we want to recommend to somebody who comes up and asks how they can integrate their external vendor system with Kubernetes? And Matt Moyer would say probably option one.
So my thinking is that anytime we do something behind a system-like interface, we get married to it for life. So let's keep that as simple as possible. Like, there's a certain amount of like keep it simple to start with, and sort of baby steps. And the more we put behind official interfaces that we're going to have to support over the long time, the more we have to get it right the first time.
Right.
We're going to have to do number one in each case, right? In terms of the interfaces that are between the node agent and the client library, or node agent and the workload. Right. Number two is really an extension of that to actually sort of move some of that code out of the workload and into behind an API. That can always be done later, right? And you could have workloads that are like, oh, hey, look, I'm a workload that assumes that I have an enhanced number two thing. Now I don't have to do this dance. Now I can just rely on it. We can always do that later in the future and extend that API between the workload and the node agent.
Yeah. Okay. I'm going to move us forward because we're running out of time for our half.
Yeah, I want to make sure Yahoo has a decent amount of time, so let's give it a couple more minutes.
Okay. So the other question is what the mechanism for delivering these credentials to pods?
I propose we skip this one. I think there's more important ones. I think this is an important one. So there's a security and availability trade-off to be made with the duration of these JOT tokens. What should we prioritize first, security or availability? In the absence of proof of possession, do we want to extend the life of these JOTs or make the integrations less available? So
why do we have to choose? Like, can't we just let the cluster administrators choose?
No, I don't think so. I think that the external integrator will, we as a community need to, if we decide to lengthen the time that we want to assign these JOTs for, we have to make sure that the external integrators will accept these JOTs for that duration. So for example, right now, AWS and GCP will only allow ID tokens from created with expirations from an hour from when they were issued at.
Are we talking about the JOTs to GCP or the JOTs within the Kubernetes system?
JOTs for the external integration, I guess. Proving to a external vendor a specific Kubernetes ODC identity.
Okay, so the question is well, I mean, so some of this is that there's this whole idea of chaining JOTs that is not necessarily going to be accepted by every what's the name of the party, but by every cloud provider in this particular case, right? And then there's the question of, okay, if we don't do the chaining thing and we actually do simpler JOTs, what is the maximum lifetime that the acceptor will actually take for those JOTs? Is that the question?
Right. Should we go to GCP and say, we need you to increase the time you would accept those JOTs to 4 hours or 8 hours. Is that something that's important?
We might be able to have that conversation with GCP, but like in a broader sense, like Kubernetes isn't going to be able to like talk to everybody who's going to accept OIDC and say like, what's a reasonable time for JOTs to live? Like, if you have a cluster, right, and you want to talk to GCP, and GCP says, I will not accept JOTs that last for more than an hour, then like you configure your cluster to have short-lived JOTs. If you want to talk to an identity provider that says, I will not accept JOTs that last for longer than 20 minutes, then like you got to issue JOTs that last for 20 minutes, right? Like,
so number two is that
come with one. I don't think we can come up with a one size fits all approach here.
Yeah, so but I would actually say that having this is, it doesn't have to be one thing for every service account. It doesn't have to be one thing for every JOT, right? You can have that lifetime be specified when you're actually requesting the JOT. You can have that lifetime be specified on the service account definition itself. And you can have policy and guardrails that are actually administrator. So you could have the administrator say, under no circumstances am I going to actually issue a JOT that's more than 4 hours, right? But then you can have the workload say, hey, give me a JOT that's only good for 20 minutes because I know that's what my provider needs. Otherwise, I get rejected.
Mm-hmm. And I do think we have, if people are approaching us to integrate their systems with Kubernetes, I think we do have more sway than you are giving us.
Yeah, but like,
it's not about sway. It's about sort of timing and rollout and like.
And like we want this to scale, right? Like we don't want to have a conversation with an identity provider every time they integrate, right? Like they shouldn't have to come to us.
So a separate question, is there any way that we can make this centralized issuer model more available than what our current API servers?
Not without chaining, which is not widely supported.
So I don't think we're going to do chaining. As I mentioned earlier, I think that the standard that we're going to support is token binding. And I think that's the standard that will be widely supported because it's already far along in the process of becoming a standard. So hopefully when that rolls out, we will have something that we can go and show other people to implement. But
all right, I think we're gonna have to cut it off to give Yahoo a decent amount of time here.
Well, I don't think I'll need more than 15 minutes. So if you guys want to go ahead on late 45, that's fine too.
Oh, okay. All right. Well, let's give it a few more minutes then.
So suppose that we aren't doing token binding. What if we had a model where the JOT minter ran separately? So the problem with the current API server architecture is there's a lot of things that'll take an API server down, and this is a non-stored resource that we are serving. So for example, if etcd goes down, this functionality of the API server doesn't necessarily need to go down.
Well, I think honestly for availability and security mechanisms, and there's a trade-off here between simplicity of administration install versus availability and security. I think having a separable identity control plane from the API server itself makes a ton of sense. And so I think in my mind, one of the questions here is this OIDC provider something that's built into Kubernetes, or is it something that can be optionally installed? What does it look like when I have like 200 clusters? I'm going to be running 200 OIDC providers and have to manage a ton of mappings, or can I actually have sort of a tree of these things with some sort of root provider that the clusters federate into, right? So those are some of the questions that I have in terms of building this in a sort of simple, sort of straightforward way to Kubernetes versus thinking about how does Kubernetes actually integrate with an external identity control plane that may or may not be paired one-to-one with a cluster, or may actually scope across a lot of clusters, and then stuff beyond clusters too.
Right. Just essentially, we need to discuss different deployment models and not rely solely on kube aggregator.
Yeah, and I think again, it's like, I think we're very much focused on looking at this through the lens of Kubernetes, but I think these systems will be more powerful, more useful if they can actually apply to off-cluster use cases too. Something I think we really need to think about here.
There's another use case here too. We've talked about in sig-auth, which is things running in Kubernetes clusters that would like to use Kubernetes user identities, like the dashboard or like Helm's tiller component. They like to, you have administrators and users who authenticate to the cluster. You want to also have those users authenticate to these systems. Would you consider making this OIDC provider suitable for that use case, or even suitable in like a web browser?
So do those things not support? Yeah, I'm trying to think how that works today.
There's kind of some ways you can make them work, but basically they all involve the system itself doing its own authentication. And sometimes, and so for the dashboard, it's kind of trying to mirror what the API server does, and supports kind of the similar mechanisms.
So I mean,
you end up with this. Can you repeat the question, Matt? Sorry, I was.
So the question is basically, could we, if we're going to have an OIDC provider built into Kubernetes, and we're using it to issue identities to pods, can we also use it to issue identities to users?
So, well, I don't think what's being proposed here is having a full-fledged OpenID Connect provider. It's just discovery plus validation. So I would be against that. Just
so one of the interesting things here is that there is an asymmetry in Kubernetes right now where the service account, like generally Kubernetes is agnostic when it comes to user identities and actually creating and validating user identities. We've broken that with service accounts, and they're somewhat special. It feels a little bit weird to actually continue to double down on having like a special thing built into Kubernetes for the Kubernetes provided identities. Because I think what we're going to find is people are going to try and there's a danger that people might abuse this to actually try and start doing user identity stuff, and it's not a great fit. And I think if we'll look at, I think if we look at the certificate approval flows that Mike did, I think that stuff is great, but I think there is some confusion of like, well, is that for users? Is that for nodes? Is that for service accounts? Like, what are the different sort of like, and the answer is it can do all of those things, but we haven't given a lot of clear guidance, and it's not clear how that stuff integrates with a bunch of the other systems we're building. So I feel like there's a little bit similar going on here.
I would opt towards offloading user credentials to a non-Kubernetes cluster OIDC provider.
And that's kind of what you can do now. So you can use like sort of the same
service accounts too. Go
Sorry,
ahead,
you guys were talking at the same time. I caught neither.
Yeah, that's sort of the model you can do right now, right? You can use the same upstream OIDC provider for your dashboard and for Kubernetes, and you can get identities that match up.
Right.
But that doesn't work for sort of out-of-the-box clusters in a lot of cases because, sort of our default, most of the default kind of tutorial kind of workflows, you end up with an administrator certificate as your sort of first credential.
Does it make sense to look at something like DEX in this context also? And actually, could we use service accounts as a provider into DEX? I mean, there's a little bit of a there's a little bit of a circular thing there, but then DEX actually becomes an OIDC provider outside of just to Kubernetes. It can be for stuff outside of Kubernetes also for Kubernetes identities. Is that, yeah.
DEX doesn't really do service accounts very well.
Well, but that's what I'm saying. Could we make DEX actually use Kubernetes as an upstream identity asserter, and then say you can use DEX to both like do OIDC to Kubernetes, but you can also use it to do OIDC from Kubernetes.
OIDC doesn't do, so DEX, when you log into it, if you're going to point it at an upstream OIDC provider, it actually requires you to be able to log into that provider. You can't just pass it a token. There is no like chaining of OIDC providers. So
no, but what I'm saying is that DEX, the upstream stuff for DEX can be OIDC or it can be other things too, right? Like,
yeah.
So we could have, okay, we're in the weeds now.
Yeah.
But
That's why I stopped presenting.
these are some of the
and
questions
we
I think
gotta
people are
get
going to
to,
ask, right?
Yeah, let's hand it over to Yahoo now.
Thank you. I'm Krishnan. My name is Krishnan. I work at Yahoo on the Kubernetes platform team. We have a stock installation of Kubernetes on bare metal, and we are doing some things with security that Matt actually wanted. We are actually consulting with Heptire to get some input on the directions that we're going in, and to making sure that we're not going too far away from where the community is going. And we have a proof of concept implementation of a system of an integration that we built with our internal authorization system for container identity, and I just wanted to share that with you guys. I'm trying to figure out. Can you see my screen?
Yes.
Okay. So our internal authorization system is called Athens, and it also can provide identities to services. It is open source, and yeah. So basically, Athens is your typical RBAC system. It has a notion of domains, which is notionally the same as Kubernetes namespaces. In each domain, you have policies and assertions where you can give RBAC access, and principals can be associated with roles, and domains can have services. You can choose to upload public keys for services in Athens itself, and you can prove your identity by having the private key, by having the service process have possession to the private key. So in terms of identity, Athens can provide multiple forms of identity like TLS certs and principal tokens, or even role tokens for scoped access. And it can be done in one of two ways. It has an API to get these identities. And the first is that the service has its own private key, and it can exchange it for a TLS cert that's minted by the Athens root CA. And the second thing, it has a provider flow where you can plug in a provider that can assert for the identity of a workload. So that flow works by so Athens so a service can say that I want to be launched by the Kubernetes service or the OpenStack service, and give Athens an input like this: that this is the provider that I want. This is my identity, and this is the attestation data that I have. It's like a JOT or some other token. Athens doesn't actually care about the format of this data, and it gives it a CSR, which is for which it needs a cert. And Athens then calls back to the provider service to make sure that the JOT is valid, and it gets a yes/no response from the provider service, and it returns TLS credentials. And those TLS credentials are ephemeral, and they last for 4 hours or something. And when the service wants to refresh it, it can refresh those credentials by using a client that sends the previous credentials, and gets the refreshed credentials. And so when Athens calls back to a provider, it basically passes down the attestation data and other attributes like the SAN DNS names and the SAN IP names requested for the CSR, and the provider is supposed to give a yes/no response. So currently, our implementation actually uses version 1, where services have their own private keys, and they can prove their identity and get an identity from Athens. We want to move to the model where we have the Kubernetes launching service that gives identities to all workloads, so that workloads don't have to manage secrets. And we want to do the bootstrap in a way that it's compatible with what Kubernetes is going to have going forward. And some assumptions that I made were like, we pull the identity on startup. Instead of pushing identities, we require the containers to ask for an identity and ask to refresh the identity, so that the pod so there's no race conditions with respect to like the pod IP being there or not there, and because the pod IP needs to be part of the SAN. The other assumptions that I made was that running pods should be able to tolerate the I assume that there's an identity agent running on the box that is providing the identity to every pod. And this basically is what I'm going to talk about is the low-level implementation of the identity agent so that they can get some feedback on it. So the other thing that we have is not really a technical requirement, but it's more of we want to abstract application owners from all the security stuff as much as possible so that it can move, so that they have a simpler interface to deal with. And we can also like change the implementation behind their backs as it were, without requiring a lot of coordinated changes if the interface were to change. So what I've implemented is a proof of concept. It's not running in production yet, but it's basically the way it works is that at the time of pod launch, so the admin basically has to authorize the Kubernetes cluster service to launch the service that they want to launch. They need to provision a service account in Kubernetes, and then they launch the pod. So there's an initializer that's watching for pods, and then it injects a flex volume and 2 containers, one for an init container to initialize the identity and a refresh container to do a periodic refresh. And it updates the pod spec, and Kubernetes asks the kubelet to launch the pod. So what I have on the pod, there is an identity agent that's running on a Unix domain socket, which is basically going to do all the talking to Athens. So when the kubelet first creates a flex volume using the volume driver that I've written here, which mounts the agent socket directory as a volume, and then the pod creation, the init container basically is able to access that the Unix domain socket and an opaque identity, and I'll come to the opaque identity what that is a little bit later. And it asks the identity agent for an identity, and this in turn talks to the kubelet API on the box to get the pod information based on the base. So okay, let me get to that. And then it generates a key pair, a JOT, and a CSR, and it makes a call to Athens. The Athens calls back to our service, that is the callback that's the launcher service callback, which checks the JOT for signature and metadata. And it uses the Kubernetes API to verify that the pod is supposed to be running on the box and so on, has the correct IP and so on. And it says yes, and Athens returns a tail assert and a service token to the workload.
So is that set specific to that pod's IP then?
Yes. So the pod's IP is part of the attestation data, and it's part of the SAN IPs in the CSR. So yeah, so every cert is unique to a pod.
So the identity agent, is that per node then?
No, the identity is per pod.
No, the identity agent is per node.
Identity agent is per node, yes.
And it has a pre-existing trust relationship with the Athens backend, right?
Yes. So okay. The bootstrap of our nodes themselves use the we do an OpenStack bootstrap. You can get credentials on the box for each node, and the node identity agent uses those credentials to prove its identity to Athens.
So just forgive my ignorance here, but do these certs work if you're accessing the pod via kube proxy, or does it only work for kind of direct IP pod to pod if you're trying to do something like TLS with it?
Mm-hmm. So I don't know the answer to that question.
So the kube proxy stuff actually terminates TCP connections and HTTP and actually rewrites some stuff. So any sort of TLS type of end-to-end thing won't work through kube proxy. It might work.
Kube proxy IP tables doesn't.
Oh, kube proxy versus I was thinking kube control proxy. I apologize.
Yeah.
Different piece entirely.
So the use case there, I guess, would be if you have a cluster IP service, you would also want the name of the service to be one of the SANs that's also on the certificates, so that when you make the end connection, you get a server certificate that has the pod IP, but also has a SAN for
that's the kind of thing I was thinking of. Yeah.
Right.
That changes. That can be dynamic.
Yeah, I think this is a general problem with Kubernetes in this scheme, is that the coupling between services and pods is looser than I think a lot of people want to assume.
Okay.
And that is both an opportunity, but also a challenge here.
So actually, in my initial version, I had like some code which actually injected the service IP for the service that was actually like link would actually match the pod selector, but it's too little because if you add a new service, then you have to change all the certs, and it kind of doesn't work. So I just stuck with adding the pod IP as part of the SAN. That's just for like a debugging access, I guess. The mutual TLS could use it, but we are actually trying to use the common name and the SAN DNS names, which are Athens specific for the TLS.
Okay, makes sense.
The two approaches people have talked about to solving that problem, Alex, has been the Google approach, which is you have a different service, which is essentially an annotated discovery service that says, okay, for this service that I want to talk to, here's the set of like identities on the back end that actually, you know, are acceptable for asserting that. And so that's sort of, I don't know, I'm trying to remember what the Google folks call that, like trusted service names or something like that.
That's the approach that Istio is currently taking as well.
Yeah, that's the approach that Istio is taking. The other approach would be that you use pod identity to actually talk to some other sort of automated, you know, certificate authority, and you get a serving cert from that, and that trusted certificate authority then actually verifies that, hey, you know, but then you have to know which services are pointing into you that you want to actually try and get certificates for, and which ones you're serving for in which cases. And so both of those kind of are not great, depending on sort of, you know, which direction you're looking at.
So so in terms of the identity agent itself, the way the flex volume works is kind of interesting. It's more complicated than it needs to be, but yeah. Anyway, so for every flex volume, what happens is that there is a top level directory under which it creates additional volume roots. So this is the volume root that's created for each flex volume, and the volume root is actually named as the SHA-256 hash of the target path that the kubelet provides. So the idea is that we create an unguessable string. We create like a directory safe name, a name that doesn't have directory paths, and we create an unguessable string so that multiple pods can use the same identity agent socket as long as they know what the opaque ID is. So what this does is that the volume driver, what it does, it creates a volume root with that name, and it adds a data.json file which has the pod attributes that were given to it at the time of volume creation, and creates a subdirectory which is actually mounted into the pod, mounted into the container. This is the final output that's given to the flex volume. This is the thing that's actually mounted into the pod. And it has a subdirectory called connect, which is basically a bind mount of the agent directory. The directory on the host that contains the agent socket. And it contains this ID file that is basically the SHA hash of the target path. So the interface to the container is that it gets an agent.sock socket file under. So let's say you mount this under /identity. So the container would see /identity/connect/agent.sock to which it needs to connect to, and it needs to provide this ID that it finds in this file. So this way we make it so that the idea is to make it hard for pods to impersonate other pods just by knowing the name. It's a SHA of the volume hash, which is specific to that node. And the identity agent itself supports two APIs. It's like post, initialize an identity, and you pass it the opaque identity, and it returns a principal token and a key PEM and cert PEM.
Hey, quick question there, brother. What your opinion is there about if the pod itself was generating claims rather than the identity agent?
Yeah. So as I said, our implementation is very specific to what we want to do in Athens. So we're not trying to generalize it a lot. In the sense that we have a notion of Athens service identity, and that's the notion that we're sticking with for internal purposes, right? So in that sense, I wasn't too worried about like who was going to so what responsibilities does the pod have in terms of asking for an identity? Do I need to ask for multiple identities and so on? So because in our world, we just assume that every pod will have one unique identity because it's like mostly internal use. And that's why this API, I think, works, because you just say, give me an identity, and we get an identity. I don't know if that answers your question.
No, that's fine. Go ahead.
So we're almost out of time. Was there stuff that you wanted to ask us?
Well, I just wanted to go over the flex volume thing, and actually I was hoping that Mike would talk about his implementation, because Matt was telling me that they had different interesting implementation of flex volume.
So Rob's also been working on an implementation as well, so I'm sure he'd be willing to chat with you offline.
Yeah, that'd be good. And the other thing,
I'm definitely gonna look into it. Thanks for the demo.
Yeah, I just wanted to show you a requirements use case of a custom integration that people might want to do.
Yeah, this is great to see.
Yeah.
And I'm happy to exchange notes with you.
Thanks.
Okay, I think we're out of time. We should call it. Thanks, everyone.
Thank you.
Thanks, everyone.